because trig equations can often have an infinite number of solutions, we often restrict the domain, and in our case, we're going to restrict the domain to any values, any x values that are between 0 and 2 pi, and that's it. So this way we avoid getting an infinite number of answers. So let's go ahead and take a look at a few basic trig equations so we can get sort of the foundation laid for how we'll solve more complicated trig equations in the future. So here's a typical trig equation: sine of theta equals square root of 2 over 2. Your first step would be to use the trig chart that we've used in class and look up under the sine column, look for an angle whose sine ratio is equal to the square root of 2 over 2. And so doing that, we see that the angle we come up with is pi over 4. Now, pi over 4 may or may not be your solution. Really, it's best to just think of this as a reference angle, because specifically what I'll need to do, and this process will be the same for all trig equations we look at, is I need to figure out which quadrant this reference angle is going to exist in, and to find that, I need to figure out what quadrant sine is positive in, because the ratio that we're working with is positive this time. So doing that, I'm thinking back to this ASTC thing we've talked about numerous times this semester. The two quadrants where sine is going to be positive is going to be here in quadrant 1, so I'll draw an angle there, and that reference angle is pi over 4. However, sine is also going to be positive in quadrant 2, so I'll draw a reference angle in quadrant 2 of pi over 4. And so now to actually find my answers, I'll have to measure these angles from the positive x-axis counterclockwise. Well, in quadrant 1, that angle is just going to be pi over 4. So if your ratio is positive, then that reference angle is in fact one of your solutions. Pi over 4 is one of our angles. In quadrant 2, however, I'm measuring this way around. And so there's a few ways you can find this. I'll show you algebraically what we're doing, but there's other ways to find this as well. I know that halfway around the circle would be 1 pi. Well, I haven't gone quite 1 pi. I've done a little bit less than that. I've done 1 pi minus 1 pi over 4. And so subtracting that or simplifying that expression, I see that the other angle that also works in this case is 3 pi over 4. So I get two answers for this equation. There's two angles that work to get me a sine ratio of positive square root of 2 over 2. And you can check this on a calculator. Type in sine of pi over 4 and make sure you get the same decimal equivalent of whatever square root of 2 over 2 is. Okay? So that's kind of the basic basis for how we'll solve some of these simple trig equations. Let's take a look at a few more examples so we can see a little more variety. This time, I again want to start with my trig chart. Under the sine column, I want to look for an angle whose cosine is equal to -1. Well, when I do that, I only see one answer. I see a theta, an angle of just pi. And because that's a quadrantal angle, pi is just 180 degrees, I can't draw that in another quadrant. There are no two quadrants where cosine is -1. It's not an angle that's in a quadrant, it's a quadrantal angle. And so to answer this question down here, our first equation had two solutions because our angle was a reference angle. It could exist in different quadrants. Our second example, that ratio, got us a quadrantal angle, an angle that ends up on a quadrant. So that is the one and only solution we get. We can get a little more complicated now as we start to add more steps to these problems, although the beginning part will be no different than what we've ever done when we've solved an equation. Let's start getting things away from the theta, the x value. So I'll go ahead and subtract square root of 3, just like we always do, and then divide by 2, and so I get sine of theta needs to be equal to the negative square root of 3 over 2. And so from here, it's going to proceed exactly the same way as the problems on the last slide went. So I'll look in my trig chart under the sine column for a ratio of square root of 3 over 2. Now there's no negative values, but there's a positive square root of 3 over 2, and that gets me pi over 3. Now remember, that may or may not be an answer. Really, it's best to think of that just as a reference angle. And so my reference angle is pi over 3, but I want to try to figure out the two quadrants where this time sine is negative, because my ratio is a negative value right there. So the two quadrants where sine is negative is going to occur in quadrant 3 as well as in quadrant 4. So I'll go ahead and add those in, and then the reference angle is what I really found. That reference angle is pi over 3 between the x-axis. That reference angle is pi over 3, again between the x-axis. I need to remeasure though from the positive x-axis counterclockwise. So in this case, I've gone a little bit past 1 pi. So adding those together, 1 pi plus 1 pi over 3, gets me a final answer over here of 4 pi over 3. That would get me a negative sine ratio. Over here in quadrant 4, I could think about it as I didn't quite do a full circle. A full circle would have been 2 pi, but I've gone a little bit less than that. So 2 pi minus pi over 3 gets me the second angle of 5 pi over 3. So again, there's my two answers, because there's two quadrants where sine could be negative. Okay, and then let's take a look at our cosine one over here. So again, I'll start out the same way. In fact, maybe you can do this beginning part in your head. If I subtract the square root of 2 and then divide by 2, here's the ratio I'd end up with, this negative square root of 2 over 2. Again, using my trig chart to look under the cosine column to figure out whose angle gets me a cosine ratio of square root of 2 over 2, I see that that angle is going to be pi over 4. There's no negative ratio in our chart, but that's okay. Think of pi over 4, though, just as a reference angle. Okay. So again, the question is always, well, what quadrants is cosine going to be negative in? Well, again, thinking back to that A, S, T, C thing, the two quadrants where cosine is going to be negative is going to be quadrant 3, or quadrant 2, and quadrant 3. So my reference angles are pi over 4 for each one. And then to finish, I'll just need to remeasure these using the methods we've talked about in this video. So that angle, the first answer is going to be 3 pi over 4. That would get me a negative cosine ratio. In quadrant 3, I could add 1 pi to that reference angle, and so this angle ends up as 5 pi over 4. So there are my two answers. And while we're talking about solving some basic trig equations, we might as well go ahead and throw in some of the reciprocal functions as well. Really no different on these problems. Start the same way as before. Let's go ahead and get the cosecant isolated. Oops. So 6 times the cosecant of theta. If I add that 10 over, would be equal to 12. If I divide by 2, then my equation becomes the cosecant of theta is equal to 2. Well, I could work with this from here, although I think it's probably a good idea just to take the reciprocal and work with just sine, cosine, and tangent. So the reciprocal of cosecant is just sine, which we can rewrite this equation as sine of theta. But then if you do this, make sure that you take the reciprocal of your ratio. So rather than have a ratio of 2 over 1, we now have a ratio of 1 over 2. So just make sure you do that when you're working with the reciprocals. And again, from here, it's going to proceed the same way the other problems proceeded. So one more time, I look in my trig chart to find out what angle has a sine ratio of 1/2, and I see that that angle is pi over 6. And that may or may not be a solution. Really, it's best just to think of that as a reference angle. And so I need to figure out the two quadrants where sine is positive, because the sine ratio is positive. In this case, I had positive 1/2. And so sine is going to be positive in quadrant 1, where everything is positive. Which means, I guess, that reference angle is in fact a solution, since we'd measure from the positive x-axis. So pi over 6 is an answer this time. And then sine is also positive, though, in quadrant 2. So my reference angle over here is pi over 6. And then remeasuring this angle, I haven't quite got to 1 pi, so I would do 1 pi minus pi over 6, and I'd find out that my second solution is 5 pi over 6. Okay, so that's how we're going to solve some of these basic trig equations, keeping in mind our solutions are always going to be between 0 and 2 pi. There's an infinite number of solutions, but we're not going to look at any of those that are outside of that domain. So these ones have 2, and there we go. There's our solutions.